Imagine a moment frozen in time. August 23rd, 2023. On this day, India's Chandrayaan-3 spacecraft etched its name in the annals of space exploration. It became the first to ever achieve a soft landing on the lunar South Pole, a region perpetually hidden from our direct view here on Earth. But what secrets does this shadowed landscape hold, making it such an object of fascination for scientists worldwide? The answer, it turns out, is a treasure of immense value: lunar ice. The South Pole is believed to be far richer in this precious resource than the Moon's northern reaches. And why all the excitement? Because this frozen water represents a potential lifeline, a key ingredient for establishing a permanent human presence on the Moon. It could even serve as a launch pad, fueling missions to distant worlds like Mars. The existence of this lunar ice wasn't always known. In fact, it was somewhat of an accidental discovery. Over 2 decades ago, a NASA spacecraft stumbled upon evidence of it during a routine mission. Then, in 2018, NASA scientists triumphantly confirmed their findings. The lunar South Pole is indeed abundant with water. Now, envision the future. Lunar settlers could tap into this vast reservoir, transforming the barren lunar landscape into a habitable environment. By employing a clever process called electrolysis, they could split the water molecules into their constituent elements: oxygen for breathable air and hydrogen for powerful rocket fuel. This would dramatically reduce the cost and complexity of future lunar missions, making them far more self-sufficient. But the significance of this ice extends beyond its practical applications. It also offers a tantalizing glimpse into the past. This ice may be as old as the Moon itself, potentially unlocking profound mysteries about the origins of both the Moon and our own planet, Earth. The truth is, water isn't as rare in the cosmos as we once thought. There may be countless other planets out there, teeming with the potential for life. We've already begun to find water vapor swirling around distant stars, and remarkably, this water bears a striking resemblance to the water found within our own solar system. This discovery suggests a mind-blowing possibility: that the water on Earth may have originated from space. Water molecules form in the swirling clouds of superheated vapor that surround young stars. As these clouds cool, the water condenses into ice, clinging to microscopic dust particles. Over vast stretches of time, these particles gradually coalesce, forming larger and larger objects: comets, asteroids, and eventually, planets. Some of these icy bodies found their way into our solar system, delivering their precious cargo of water to Earth and the Moon. Scientists believe that the lunar ice may have arrived eons ago, hitching a ride on water-rich asteroids that collided with the Moon's surface. The implications of all this are enormous. The lunar South Pole presents an ideal location for humanity to establish a permanent moon base. Picture it: interconnected brick domes linked by a network of underground tunnels, bustling with activity. People hunched over computers, conducting research, others cruising across the lunar surface in specialized vehicles, mining precious resources. But how do we build such a base? One approach might be to transport massive prefabricated shelters from Earth. However, there may be a more efficient, more sustainable way. Throughout human history, whenever we've ventured into new territories, we've always relied on the resources available in the immediate environment. This is how we adapted, survived, and thrived, ultimately spreading across the globe. Why not apply the same principle to lunar colonization? What resources does the Moon offer? We know about the ice, which can be converted into water. But the Moon lacks the lush vegetation and readily available food sources of Earth. However, the Moon does possess 2 key resources: mineral wealth and abundant sunlight. Unlike Earth, where the sun rises and sets in a predictable cycle, the lunar poles offer a unique spectacle. The sun perpetually skirts the horizon, providing a near-constant source of solar energy. Imagine living in a world bathed in eternal sunlight. Solar panels would thrive, and we could harness not only the sun's light, but also its heat. In essence, we need to utilize every resource available to us. If the process of extracting oxygen yields surplus metal, we must find a purpose for that metal. We have a responsibility to treat the lunar environment with respect, just as we should treat our own planet. That's why scientists are exploring ways to transform the moon's most abundant resource, regolith, lunar soil, into durable bricks. They've developed ingenious methods for creating these moon bricks. One approach involves using concentrated sunlight to melt the lunar dust, layer by layer, essentially creating a 3D printer that utilizes lunar soil as its raw material. Engineers have also experimented with solar ovens and microwave technology to bake and fuse the regolith into solid bricks. So, perhaps the future holds a lunar brick factory, churning out building materials for regolith houses. It's like Minecraft come to life. Whenever you discover a new resource, the first instinct is to build a house with it. If these bricks prove successful, they could be used to construct entire buildings, providing protective shells for inflatable modules, or even repurposing abandoned lunar landers. The possibilities are vast. For decades, the origin of the moon has been shrouded in mystery, sparking countless theories. One intriguing idea proposed that our lunar companion began as two separate diminutive moons. Over eons, these celestial twins gradually merged, giving rise to the single larger moon we observe today. This hypothetical merging, it was argued, could explain the compositional differences between the moon's near and far sides. However, this two-moon theory wasn't without its flaws. A primary issue was the surprisingly smooth transition between the two sides of the moon. If indeed formed from two distinct bodies, scientists expected a far more abrupt shift in composition and geological features. The lack of such a sharp boundary left researchers puzzled. But recently, thanks to the tireless work of NASA's Grail orbiters, a new chapter in lunar science has begun. These dedicated spacecraft spent over a year meticulously circling the moon, mapping its surface and analyzing its composition with unprecedented precision. Using the wealth of data collected, scientists created approximately 360 complex computer simulations. These simulations modeled various scenarios, each involving impacting objects of different sizes, colliding with the early moon at varying speeds. By comparing the simulated outcomes with the real moon we see today, researchers sought the scenario that most closely matched reality. Finally, after decades of speculation, the mystery began to unravel. The answer, it seems, lies in a cataclysmic collision with a dwarf planet approximately 4.3 billion years ago. This immense object, slightly larger than Ceres, a dwarf planet residing in our solar system with a diameter of 580 miles, large enough to swallow France or Germany whole, slammed into the moon near its south pole. The impact was of unimaginable force, forever altering the face of the moon. It left a scar stretching 3,500 kilometers, a distance that would take a jet plane nearly 14 hours to traverse. This colossal crater effectively engulfed the entire near side of the moon, causing extensive damage to its mantle. The collision also birthed the South Pole Aitken Basin, an impact crater of staggering proportions, measuring 2,500 kilometers in diameter, an area equivalent to the combined size of the UK and Germany. The formation of this basin was a pivotal moment in the moon's history, marking the second largest known impact crater in the entire solar system. In the aftermath of the collision, a powerful wave of heat radiated across the lunar surface. This thermal pulse scattered remnants of rare heat-loving minerals across the near side, ultimately leading to the formation of the Procellarum creep terrain, or PKT. The PKT is a compositional anomaly characterized by a high concentration of potassium, K, rare earth elements, REE, phosphorus, P, and other exotic elements like thorium. These minerals, delivered from the depths of space by the impacting dwarf planet, can be seen as a unique gift. Over countless millennia, the moon endured numerous other impacts, each one further deepening the already vast South Pole Aitken Basin. This relentless bombardment gradually thinned the lunar mantle on the near side. Simultaneously, the heat emanating from the creep minerals caused localized melting within the mantle. This internal heating inadvertently triggered a surge in volcanic activity on the near side. Molten lava erupted onto the surface, filling ancient craters and creating the dark, smooth plains known as Lunar Maria, the seas that define the face of the man in the moon. This is how the lunar mare were born. This groundbreaking research comes from collaborative efforts by scientists from Brown University, Purdue University, Stanford University, and NASA's Jet Propulsion Laboratory, JPL. Their findings have been published in the Journal of Geophysical Research. Planets, offering a detailed account for those eager to delve deeper. Despite these advances, many lunar mysteries remain unsolved. A high-priority goal is a sample return mission from the South Pole Aitken Basin. Analyzing these samples promises to reveal the moon's age, its geological history, and the precise composition of its crust and mantle. Another key target is the Moscovians Basin, a vast lava plain on the far side of the moon. Studying this region will shed light on the fundamental differences between the near and far sides and how the far side came to be. Unlocking these secrets is not only vital for understanding the moon's history, but also for advancing space exploration in general. Scientists use the moon as a benchmark for dating other planets and celestial bodies, establishing a timeline for the evolution of our solar system. But the story doesn't end there. Stay tuned for more thrilling research and discoveries, because beneath our feet, the moon is not the dead, inert rock we once thought. Imagine standing on the lunar surface, the airless vacuum pressing in. A sudden tremor rocks the ground. For years, the scientific consensus held that the moon was geologically inactive. However, recent evidence suggests otherwise. Researchers at the University of Maryland have identified 266 enigmatic ridges on the moon's far side, hinting at recent, perhaps ongoing, geological activity. Are there really moonquakes happening even now? Well, in a sense, yes. Let's turn our gaze to the lunar surface, specifically to those intriguing ridges. These formations are situated within volcanic regions that solidified between 3.2 and 3.6 billion years ago. And yet, they possess an unexpectedly youthful appearance. Typically, these ridges appear in clusters of 10 to 40. You'll often find them in areas where the moon's surface exhibits structural weaknesses. Now, when astronomers use the term recent, it's crucial not to interpret it literally. They aren't referring to events of the last year or even the last decade. Most scientific models have suggested that the moon's geological activity ceased around 2.5 to 3 billion years ago. But the latest data hints at the possibility that these formations have remained active within the last billion years. Some of the smaller ridges appear to have formed as recently as 200 million years ago. A blink of an eye on the lunar timescale. This implies that the moon might still be undergoing geological changes even today. These discoveries challenge our existing understanding of the moon's history and its evolutionary path. But how did scientists arrive at these conclusions? Researchers from the University of Maryland and the Smithsonian Institution employed a technique known as crater counting to estimate the age of these lunar ridges. The principle is simple. Surfaces with fewer impact craters are younger, while surfaces densely covered in craters are older. Furthermore, the analysis revealed that some ridges actually cut through pre-existing craters, suggesting they likely formed around 160 million years ago. In geological terms, this is incredibly recent, implying that the ridge-forming processes could still be actively shaping the lunar landscape. Interestingly, the ridges on both the near and far sides of the moon exhibit similar characteristics. This suggests they may have originated from the same underlying geological processes, sculpted by the same forces. These forces might include the moon's gradual shrinking, thermal contraction, and subtle shifts in its orbital path. We'll delve into that a bit later. Another compelling argument supporting the idea of a still active moon comes from decades-old data gathered during the Apollo missions. These missions detected shallow moonquakes using the Apollo Lunar Seismic Experiment, recording 28 quakes with magnitudes ranging from 1.5 to 5. Researchers now suspect that these ridges may be connected to this ongoing seismic activity. Now let's talk about the bizarre shrinking of our natural satellite. Scientists theorize that the moon formed approximately 4.5 billion years ago, following a colossal impact between a Mars-sized object and the early Earth. This catastrophic collision likely ejected vast quantities of superheated material into space. Over eons, this material coalesced, forming the moon. In its infancy, the moon was a molten world, racked by intense volcanic and seismic activity. So, imagine a molten sphere, a chaotic mix of elements, adrift in the void. But when did this molten chaos finally solidify? Scientists have pinpointed the moment, approximately 4.43 billion years ago. This was a pivotal turning point, not only for the moon, but also for Earth. After all, the giant impact that birthed the moon may have also delivered the final stabilizing blow that made Earth habitable for life. Billions of years passed. The moon gradually cooled, contracted, and eventually transformed into the rocky sphere that illuminates our nights. But the moon isn't entirely rigid even now. It continues to cool, and this slow cooling of its core may be a primary driver of the moon's continued activity. As it cools, the moon's interior contracts, leading to the formation of cracks and shifts within the lunar crust. One of the most visible manifestations of this contraction can be observed in the lunar maria. See those large dark patches on the moon? These are the maria, vast plains formed when lava flowed into ancient asteroid impact craters and subsequently solidified. Over vast stretches of time, the cooling and contracting crust sculpted these wrinkle ridges. Another factor contributing to the ongoing geological activity could be the moon's gravitational interactions with Earth. These incessant, powerful interactions likely induce stress on the lunar surface, triggering tectonic movements. This is all fascinating, but could this activity on the moon actually pose a threat to humans? In a way, yes. The moon has long been considered a stable platform for future lunar bases and resource extraction. However, the revelation of this ongoing geological activity is somewhat concerning. If the surface is still shifting, future settlements, infrastructure, and mining operations could face significant risks. That's why, at this juncture, we require advanced seismometers and ground-penetrating radars to gain a more comprehensive understanding of these movements. This will enable us to assess potential hazards before embarking on any long-term lunar missions. And there's yet another potential challenge that future lunar missions might encounter: moon dust, also known as regolith. The Apollo astronauts quickly discovered that this jagged, incredibly fine dust has a knack for getting absolutely everywhere, and it can inflict damage on spacesuits and equipment. Imagine the year is 2026. Humanity is once again setting its sights on the moon, but this time, the stakes are even higher. A new study from Texas A&M engineers has revealed a potentially crippling problem: the lunar regolith. This isn't your ordinary dust. It's a menace kicked up by landing and departing rockets, turning into a high-speed collision hazard. With multiple spacecraft ferrying crews and vital supplies to the lunar surface, the risk is amplified. Lunar regolith is a mixed bag, ranging from microscopic dust particles to sizable rocks. The primary component is a fine silicate material, averaging around 70 microns, about the width of a human hair. This abrasive dust formed over eons as relentless meteor and asteroid impacts pulverized the moon's surface into a fine powder. Unlike Earth, the moon possesses a virtually non-existent atmosphere. With almost no wind or water erosion, the dust remains jagged and unforgiving. Compounding this, constant exposure to the sun's solar wind imbues the regolith with an electrostatic charge, making it cling stubbornly to anything it encounters. The Apollo astronauts learned this lesson the hard way. Moon dust infiltrated their suits, wormed its way into their lunar landers, and adhered to every surface imaginable. Even worse, it proved to be a health hazard, causing eye irritation and respiratory problems within the confines of their spacecraft. But for now, this dust problem seems to be an issue for the future. An even greater challenge looms: securing a sustainable water source to support extended lunar missions. China is poised to tackle this head-on. The nation is gearing up for an ambitious mission to locate hidden ice deposits on the moon. As part of the Chang'e 7 mission slated for 2026, a specialized flying robot will be deployed to explore the perpetually shadowed depths of craters near the moon's south pole, where ice may be trapped in abundance. If this mission succeeds in confirming the existence of substantial ice reserves, it would be a paradigm shift for future lunar endeavors. Astronauts would gain access to a readily available water source and even the potential to manufacture rocket fuel for interplanetary travel. This mission represents a pivotal step in China's ambitious plan to land astronauts on the moon within the next 5 years. While past missions, such as the Chang'e 5 probe and observations from NASA and Indian spacecraft, have hinted at the presence of water, scientists believe that significant accessible ice deposits are the key to enabling long-term lunar habitation. The moon's south pole is riddled with incredibly deep craters, and experts theorize that vast quantities of ice may be lurking within their permanently shadowed interiors. The flying robot will attempt to navigate and explore one or more of these treacherous craters after landing. Discovering usable ice would dramatically reduce the cost and logistical complexity of long-duration moon missions, paving the way for astronauts to live and work on the lunar surface for extended periods. Furthermore, some scientists speculate that these lunar ice deposits may hold clues about the origins of life beyond Earth. Regardless of whether we find water and conquer the challenges of lunar dust, the recent revelation of young lunar ridges is a game-changer. If the moon is still geologically active, it forces us to confront the unsettling reality that we may not know as much about our celestial neighbor as we once thought. What other secrets does the moon hold? Are we truly prepared for the possibility that this seemingly lifeless satellite is far more dynamic than we ever imagined? Future missions, potentially fraught with unforeseen risks, will undoubtedly reveal more. Now, let's turn our gaze to Mars, the red planet, and its two peculiar moons, Phobos and Deimos. Aside from their irregular shapes, these moons seem unremarkable until we delve deeper. In recent years, scientists have stumbled upon a perplexing phenomenon on the surface of Phobos, one that defies easy explanation. What is this enigma? And what does it reveal about the history and evolution of our solar system? American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. It is interesting to note that virtually all the planets in our solar system bear names derived from Greek and Roman mythology. Mars, or Ares in Greek, is the renowned god of war. Consequently, it seems fitting that the satellites orbiting this red planet were named after the sons of Ares, Phobos and Deimos. However, these seemingly beautiful names carry ominous connotations: fear and terror. In 1971, NASA's Mariner 9 spacecraft captured the first close-up images of these Martian moons. These images revealed that Phobos and Deimos were unlike anything we had seen before. They possessed bizarre, irregular shapes and followed strange, unstable orbits. Furthermore, no other moons in our solar system orbit their parent planet as closely as Phobos and Deimos orbit Mars. Although they are close, an observer standing on the surface of Mars would likely struggle to see them. The curvature of the planet obscures Phobos and Deimos from view. Even if you were positioned along the Martian equator, Phobos would appear as nothing more than an ordinary asteroid, while Deimos would resemble a distant star. This is because these satellites are mere fragments compared to our own moon. They are the smallest and dimmest moons in the entire solar system, a stark contrast to the powerful and intimidating names they bear. It would seem that everything about these two satellites is now understood. But that is not the case. There is a problem. You see, scientists are struggling to reconstruct the history of Let's journey across the vast gulf of space, examining cosmic wreckage for clues about events that transpired billions of years in the past. Dents, scratches, fissures. Each imperfection on these celestial bodies whispers a story of ancient impacts and untold cosmic dramas. For many years, astronomers believed Phobos and Deimos, the moons of Mars, were twins, forged from the same cosmic stuff. They thought these Martian satellites mirrored each other, much like their namesakes from Greek mythology. However, NASA's Viking orbiter shattered this illusion with stunning new photographs. These images revealed a stark contrast between the two moons. Phobos was scarred, its entire surface etched with a network of colossal grooves. Imagine a series of long, deep gashes slicing across Phobos from end to end. One might dismiss them as typical space debris damage, a common sight on celestial objects. And it's true, other moons and asteroids bear similar markings. But the sheer density and scale of the grooves on Phobos are unparalleled. The entire moon is crisscrossed with these trenches, some reaching up to 12 meters in length and a staggering 200 meters in width. But the story doesn't end there. Some of these grooves intersect, forming a complex web of scars. This reveals that Phobos endured not one, but multiple cataclysmic events. The question remains, what forces shaped this battered landscape? Scientists are still piecing together the puzzle. However, several compelling theories offer glimpses into Phobos' violent past and hint at its ultimate destiny. The first theory points to an asteroid impact, a cosmic collision of immense power. A prominent feature on Phobos is the Stickney crater, a massive depression nearly 6 kilometers wide. It's named after Angeline Stickney, the wife of Asaph Hall, the astronomer who discovered Phobos and Deimos. A charming tribute indeed. The asteroid impact theory suggests that a massive space rock slammed into Phobos, creating the Stickney crater and radiating shockwaves that fractured the moon's surface, forming the extensive groove network. Initially, this seemed plausible. However, closer examination revealed a critical flaw. The grooves don't originate within the crater itself, but rather radiate outwards from its vicinity. Therefore, the grooves weren't directly caused by the impact. Furthermore, how could a single impact explain the intersecting grooves? Was it simply a series of cosmic coincidences? The search for answers continued. A second theory proposes that space debris, rather than a single massive impact, is responsible for the grooves. In this scenario, an initial collision on Phobos ejected countless rocks into space. While some were lost to the cosmos, others, small enough to be influenced by Phobos' weak gravity, were pulled back towards the moon. Imagine these rocks hurtling back towards Phobos at steep angles, impacting the surface, bouncing away, and then crashing down again. Due to Phobos' minimal gravity, these rocks couldn't permanently adhere to the surface. Instead, they would have been repeatedly drawn in and flung away, a relentless cycle of impacts spanning millennia. This theory elegantly explains the intersecting grooves. The returning rocks would have repeatedly struck specific areas, gradually carving out the observed trenches over vast stretches of time. However, this theory also suffers from a significant challenge. Where is the evidence? We see no lingering boulder fields on Mars or its moons. The ejected debris should have eventually succumbed to gravity, either falling onto Mars or becoming permanent fixtures on Phobos. If this theory held true, we'd expect to find layers of space rock beneath the surface dust. Yet, no such evidence has been found. Frustrated but undeterred, astronomers pressed on, seeking a more satisfactory explanation. Perhaps the Stickney crater was a red herring. Perhaps the true culprit was something far more powerful, something connected to the red planet itself. A third, more radical theory implicates Mars directly. Previous theories assumed Phobos and Deimos were born from Mars, chunks of the planet blasted into orbit long ago, much like our own moon's origin story. But what if that wasn't the case? Data from NASA's Mars Global Surveyor reveals that Phobos and Deimos are composed of materials predominantly found in meteorites and asteroids. This suggests a different origin story. What if Phobos and Deimos are captured asteroids? Consider the asteroid belt situated between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists propose that they once resided within this belt. However, at some point, they were ejected from the asteroid belt and ensnared by Mars's gravitational pull. This phenomenon is known as asteroid capture. While asteroid capture is not uncommon, the longevity of Phobos and Deimos' orbits around Mars is peculiar. They have remained in relatively stable orbits for billions of years. Furthermore, Mars's thin atmosphere makes capturing asteroids a difficult feat. In theory, these captured asteroids should have drifted away from Mars at the first opportunity. But fate had other plans. Imagine, if you will, these brave pioneers of life hurtling through space, only to find themselves ensnared by the unforgiving grip of Mars. Instead of a new home, they met their doom. In this cosmic drama, Mars emerges as the unlikely villain. By peering into the echoes of the past, we've uncovered tantalizing clues to Mars's destructive nature. Consider the enigmatic grooves etched across the surface of Phobos, Mars's innermost moon. These aren't mere scratches. They are the scars of a celestial struggle, potentially caused by the immense tidal forces exerted between Mars and its captive moon. Earth and our own moon engage in a similar gravitational dance, subtly distorting each other across vast distances. But the proximity of Phobos to Mars amplifies these forces to a cataclysmic degree. The immense gravity of Mars is relentlessly tearing Phobos apart. Every century, this doomed satellite spirals 0.7 meters closer to its demise. It shrinks by as much as 2 meters, its structure weakening with each agonizing orbit. The smaller Phobos becomes, the more vulnerable it is to the tidal forces, resulting in the strange and haunting grooves that crisscross its surface. In a mere 30 to 50 million years, Phobos faces two equally grim possibilities. Either a head-on collision with Mars or a catastrophic disintegration, scattering its remains into a debris field. From that debris, a ring system will emerge, adorning Mars with cosmic jewelry reminiscent of Saturn and Neptune. This is why Phobos carries the somber title of the doomed Martian moon. These are, of course, theories, but they paint a vivid picture of the dynamic and often violent nature of celestial objects. The more we unravel their secrets, the closer we get to understanding the very origins of Mars and the other wonders of our solar system. Should humanity ever establish a foothold on Mars, the study of its moons will undoubtedly be invaluable. Let's hope that the upcoming Martian Moons Exploration, MMX mission, will unveil the most captivating secrets hidden within these Martian satellites. And so, the dream of a cheese moon melts away. The shiny orb that graces our night sky, whether a full disk or a crescent sliver, possesses a complex, layered structure, much like our own Earth. Roughly 2 decades ago, scientists began scrutinizing the moon's rotation. Their findings pointed to a fluid outer core, but the inner core remained stubbornly elusive. Was it a solid, unyielding sphere or a molten, seething heart? Now, clarity has emerged. Astronomers have meticulously compiled data from multiple missions, including the historic Apollo missions, where astronauts themselves walked upon the lunar surface and gathered invaluable data. They've also employed a sophisticated technique known as seismic data analysis. Think of earthquakes on Earth. When the ground trembles, it unleashes waves that propagate through the planet. By detecting and analyzing these waves, scientists can construct a detailed map of Earth's interior. The same principle applies to other celestial bodies, including our moon. When moonquakes occur, they generate sound waves. By carefully monitoring and interpreting these waves, scientists can create a detailed cross-section of the moon's interior, revealing its layered structure, composition, and arrangement. To probe the moon's depths, they also use a technique called laser ranging. This method involves precisely measuring the distance between Earth's surface and the moon. And the result? Our natural satellite possesses a dense, solid inner core composed of iron, mirroring the structure of Earth. This iron ball stretches roughly 500 kilometers, 310 miles wide, representing nearly 15% of the moon's total size. Imagine a ball of solid iron, nearly the size of France, nestled deep within the moon. Furthermore, researchers have uncovered compelling evidence supporting the theory of lunar mantle overturn. The mantle, the layer between the moon's surface and its core, appears to have shifted and churned over eons. This movement could explain the presence of iron-rich elements on the lunar surface. During volcanic activity, material from the mantle was carried upwards. Some of the dense material within this volcanic rock, much like heavy sediment in a river, sank back down through the lighter crust material, ultimately reaching the core mantle boundary. This creates a cycle where mantle material rises during volcanic eruptions, transports iron-rich elements to the surface, and then sinks back down. Another puzzle has long vexed scientists. What caused the moon's magnetic field to weaken and nearly vanish over time? Now, with our newfound understanding of the iron core and the global mantle overturn, we may be on the verge of unlocking the secrets of the moon's magnetic history. Understanding the nature of the inner core offers a profound glimpse into the moon's past and, by extension, the history of our entire solar system. One widely accepted theory posits that the Moon was born from a cataclysmic collision between Earth and a Mars-sized object in the early solar system. Imagine, for a moment, our young solar system, billions of years ago. A cosmic game of planetary billiards is underway, and a rogue object is hurtling toward the infant Earth. This is the leading explanation for the Moon's origin. The Large Impact Theory. The collision was catastrophic, a violent smash that tore a massive fragment from the still molten Earth. To grasp the scale, picture this: a US nickel next to a tiny green pea. That's roughly the size difference between our planet and its moon. This colossal chunk, ripped from the Earth, was flung into orbit. This event likely unfolded approximately 95 million years after the formation of our solar system. The impactor itself, a planetary body perhaps a tenth of Earth's mass, roughly the size of Mars. The evidence stacks up. Earth and the Moon share a similar composition, hinting at their shared origin. But this isn't the only theory. Another suggests that the Moon was an innocent wanderer, a celestial object drifting through space when it was ensnared by Earth's gravitational pull. It was captured, forever bound to our planet's orbit. There's even a bolder hypothesis. Earth, the planetary thief, stole the Moon from Venus. In that case, the Moon certainly upgraded its view. While Earth and the Moon share rocky similarities, their atmospheres are vastly different. The Moon's atmosphere is incredibly thin, a wisp of exotic gases like potassium and sodium, elements absent from the atmospheres of Mars, Venus, and our own Earth. And the lunar rocks themselves are bone-dry, devoid of water. But this doesn't mean the Moon is entirely without water. Let's journey back to the 17th century. Early astronomers peering through their telescopes noticed large dark patches on the lunar surface. One astronomer, captivated by their appearance, likened them to oceans and christened them Maria, Latin for seas. This term stuck, appearing on lunar maps to describe these shadowy regions. Mare Tranquillitatis, the Sea of Tranquility, became forever famous as the landing site of Apollo 11. But these dark spots are not oceans. They are vast plains of hardened lava, remnants of ancient volcanic eruptions. These eruptions, eons ago, smoothed the lunar surface, creating expansive basalt plains. Yet, in the late 1800s, a keen observer realized the Moon lacked a substantial atmosphere. Without an atmosphere, there are no clouds, no protective layer to prevent water from evaporating into space. The prevailing view was that any lunar water would vanish instantly. The Moon was considered utterly irrevocably dry. Then, in 1961, a physicist dared to challenge this dogma. He proposed that water ice could exist in permanently shadowed regions, areas on the Moon where sunlight never penetrates. These perpetually dark zones, shielded from the sun's heat, could be cold enough to preserve water ice for billions of years. However, the Apollo missions threw a wrench in the works. Astronauts returned with lunar soil samples, and initial analysis revealed no trace of water. The scientific community reverted to its earlier conclusion: the Moon was a desert. But the quest didn't end there. In the 1990s, NASA redirected its focus, scrutinizing these shadowed craters. They discovered high concentrations of hydrogen, a key component of water, near the lunar poles. Still, certainty remained elusive. The investigation continued, eventually uncovering hydrogen trapped within minuscule beads of volcanic glass. This suggested that water was present on the Moon during ancient volcanic activity, long before the volcanoes fell silent. Furthermore, the evidence hinted at even greater water reserves in the Moon's distant past. Finally, in 2020, NASA's SOFIA mission delivered the breakthrough. They detected water on the Moon. It was hidden within grains of lunar dust or clinging to the surface in sunlit areas. No sprawling oceans, but water nonetheless. The mystery now shifts to its origin. How did water even reach the Moon? The Moon's early history was turbulent, mirroring the chaotic formation of other planets and moons in our solar system. One theory suggests that comets, icy remnants from the solar system's birth, bombarded the lunar surface, delivering water. Perhaps this process continues even today, with comets still crashing onto the moon. Imagine the scene. A constant barrage of icy micrometeorites colliding with the lunar surface, stirring up dust and interacting with the solar wind. It's a messy, dynamic environment. The search for answers continues because, inevitably, where there's water, there's the potential for life. The ice locked away in the moon's polar craters could hold vital clues about the origins of life on Earth. Imagine looking up at the night sky. The familiar, comforting glow of the moon is gone, replaced by an eerie, blood-red orb. People stop in their tracks, cars abandoned on highways, heads craned skyward in disbelief. In cities, the streets fill with bewildered onlookers. Balconies and rooftops become makeshift observatories as everyone stares, transfixed, at the crimson moon. Some scream, convinced it's the end of days. Others frantically seek shelter, gripped by primal fear. The moon, usually a serene white, appears as if drenched in crimson paint. But there's no need for alarm. What you're witnessing is a rare and breathtaking astronomical phenomenon. A total lunar eclipse, a spectacle known as the blood moon. Let's journey out into space to understand what's happening. There, in the heart of our solar system, blazes the sun. Circling it are the planets, including Mercury, Venus, and our own Earth, accompanied by its faithful companion, the moon. Earth completes its orbit around the sun in 365 days. Meanwhile, the moon diligently circles our planet, completing its journey in roughly 27 days. As Earth orbits, it casts a vast shadow into space. This shadow, cone-shaped, gradually narrows as it extends outwards. The moon, some 238,000 miles distant, a distance equivalent to almost 10 times the length of Earth's equator, occasionally passes through this shadow. At this immense distance, the shadow's width is still about 2.6 times the moon's diameter. When the moon enters this shadowed zone, direct sunlight is blocked. Logically, it should vanish from sight. Yet, instead, it transforms into a mesmerizing red. This is because sunlight, even though directly blocked, still reaches the moon, albeit indirectly. The sun's rays graze the Earth's atmosphere, scattering as they pass through. Most of the blue light is filtered out and dispersed. However, the red and orange wavelengths, longer and more resilient, continue their journey, bending around the Earth and eventually reaching the lunar surface. Voila! The blood moon appears. This same phenomenon explains the fiery hues of sunsets and sunrises. As the sun dips below the horizon, its light traverses a greater distance through the atmosphere, scattering the blue light and leaving the red and orange to dominate the sky. Now, imagine you are standing on the moon's surface during a total lunar eclipse. Looking up, you would see Earth positioned directly between you and the sun. A solar eclipse from a lunar perspective. The Earth's surface would appear plunged into total darkness, with only the sun's corona, a shimmering halo of light illuminating the edges of our planet. From the moon, Earth would appear almost the same size as the moon appears to us, a breathtaking sight. Such a vibrant red lunar eclipse is a relatively rare event, requiring a specific alignment of celestial bodies. First, the moon must be full. Typically, we experience about 2 total lunar eclipses each year. In the year 2038, a fortunate few will witness as many as 4. The eclipse itself can last up to an impressive 108 minutes. But such prolonged displays are uncommon. The last time a blood moon of that duration graced our skies was in the year 2000. Centuries ago, before our understanding of celestial mechanics, the sight of a blood-red moon instilled fear and dread. It was seen as an ominous sign, a harbinger of misfortune. However, those with knowledge of astronomical cycles could exploit this fear. Christopher Columbus, for example, possessed an astronomical almanac and knew when a lunar eclipse was imminent. He famously used this knowledge to intimidate the inhabitants of the Caribbean islands by predicting the arrival of the blood moon. But let's journey back even further, to a time when the moon itself was a molten, fiery sphere. Imagine that, 4.5 billion years ago. Our solar system was a chaotic arena, filled with dust, asteroids, and nascent planets engaged in a cosmic game of billiards. Earth, still cooling from relentless asteroid and comet bombardments, was a volatile world. Then, from the depths of space, emerged Theia, a Mars-sized protoplanet, its orbit unstable and erratic, spiraled inexorably towards Earth. A collision was unavoidable. And so it happened. One of the most cataclysmic events in the history of our solar system. Theia struck Earth a glancing blow, ripping away a substantial chunk of Earth's crust and flinging it into space. Earth, in turn, absorbed a portion of the rogue planet. The debris from this colossal impact swirled around Earth, forming a ring reminiscent of Saturn's. Over time, these fragments collided and coalesced under the influence of gravity, eventually forming the Moon, our celestial companion. Remarkably, there's a compelling theory suggesting that this very collision may have been instrumental in the emergence of life on Earth. Theia's impact, occurring at a precise angle, was crucial. A head-on collision would likely have vaporized both planets in a cataclysmic explosion. A mere tangential brush wouldn't have ejected enough debris into orbit to form the Moon. But fate intervened. The Moon stabilized Earth's axial tilt, creating predictable seasons. The impact shattered the planet's rigid crust, allowing vast oceans to form. Oceans that would become the cradle of life. Furthermore, the merging of Earth's and Theia's cores resulted in a powerful magnetosphere, shielding all nascent life forms from harmful solar radiation. The Moon, in concert with the Sun, governs the tides, its gravitational pull shaping the very rhythm of our planet. Its gravity seems to draw water. Imagine the Earth as a giant ball of water, suspended in the void. Now picture the Moon, not just reflecting sunlight, but exerting its own pull, a subtle but constant tug on our planet. The Sun, too, plays its part in this celestial dance. If our water Earth had no land, the gravitational forces would create two massive bulges, mountains of water, one facing the Moon, the other facing the Sun. As the Moon journeys around the Earth, this watery mountain follows. Out in the open ocean, with precise instruments, you could measure the Moon's influence, its power to draw water towards itself, raising the sea level by a few inches, perhaps 4 to 6. The Moon is gravitationally locked to Earth, eternally showing us only one face, much like Mercury's relationship with the Sun. However, this cosmic dance is not static. The Moon is slowly, relentlessly, drifting away from us, receding at a rate of about 1.5 inches per year. It doesn't seem like much, but over vast stretches of time, say 600 million years, this subtle drift will have a dramatic effect. The Moon will shrink in our sky, becoming so small that those spectacular lunar eclipses we cherish will become a thing of the past, lost to the ages. Look closely at the Moon's surface. Do you see that prominent crater? That's Tau. During a full moon, it becomes strikingly visible, its bright rays extending thousands of miles from its center. This is the youngest major crater on the Moon, a relatively recent scar on the lunar landscape. Scientists believe it was formed by a meteorite impact roughly 109 million years ago. Imagine that. Dinosaurs still roamed the Earth back then, during the Cretaceous period. They may have witnessed this cosmic collision, a blinding flash in the night sky, a cataclysmic explosion that would have resembled a colossal firework display. Humanity has always been drawn to the Moon, a beacon in the night. We have launched numerous missions to explore its mysteries. To date, 12 brave souls have walked on its surface, leaving their footprints on another world. The Moon's gravitational pull is only 1/6 of Earth's. Imagine stepping onto the lunar surface. If you weigh 180 pounds here on Earth, the scales on the Moon would register a mere 30 pounds, about the weight of a small dog. This explains the peculiar movements of the astronauts, their bouncing strides and slow-motion falls. You'd feel incredibly strong. An average person who can lift 130 pounds on Earth could hoist a motorcycle or even a grizzly bear on the Moon. The surface of the Moon is blanketed in regolith, a fine, powdery lunar dust that covers the solid rock beneath. This dust is remarkably good at preserving impressions. Consider the most famous footprint on the Moon, a symbol that has fueled countless conspiracy theories. Here's the footprint, and here's the boot that supposedly made it. But wait, the boot appears to have a completely flat sole. The explanation is quite simple. The astronauts wore specialized overboots designed for walking on the lunar surface. These overboots had soles that perfectly matched the famous footprint. Beyond footprints, we have left behind a collection of fascinating artifacts on the moon. Lunar rovers, a golf ball, flags planted in the lunar soil, and even bags of human waste. There are also remnants of broken satellites and discarded rocket parts. In total, we've deposited around 413,000 pounds of human-made objects on the moon. That's the equivalent weight of 3 fully loaded passenger airplanes or 31 adult elephants. Looking ahead, we are planning a renewed push to explore the moon. New lunar landers will be dispatched to scour the surface for valuable natural resources. The moon is also an ideal testing ground for new generations of rovers. There's even talk of constructing a lunar orbital platform, a sort of international space station in lunar orbit, known as the Lunar Orbital Platform Gateway. This gateway would serve as a launch pad for missions deeper into space. By launching from lunar orbit, spacecraft would require significantly less fuel to escape Earth's gravity, saving vast sums of money. Scientists are particularly interested in extracting water from the moon's surface. Evidence suggests that ice deposits exist, primarily in the permanently shadowed craters near the lunar poles. Perhaps we will send a rover equipped with a drill, capable of penetrating several feet into the lunar soil in search of this precious resource. Humanity already possesses the technology to establish a permanent lunar colony. The journey would take approximately 3 days. The primary challenges lie in transporting sufficient solar panels and building materials to the moon. With no atmosphere to shield inhabitants from solar radiation, underground habitats would be essential. Modern 3D printing technology could revolutionize construction, making it faster and more efficient. However, sustaining a lunar colony presents formidable logistical hurdles. Food, water, and oxygen would need to be constantly resupplied from Earth, and each rocket launch costs millions of dollars. For now, large-scale lunar colonization remains a distant prospect. In the near term, the moon may become a destination for space tourism. Imagine boarding a spaceship on Earth, embarking on a 3-day voyage to lunar orbit. You transfer to a lunar module and descend to the surface. You explore the craters in a rover, then return to the lander. The engines ignite, carrying you back to orbit, where you dock with the waiting spaceship for the return journey to Earth. A week-long vacation unlike any other. Technological progress continues at an incredible pace. In recent years, the clarity of lunar surface images has been dramatically enhanced. A multitude of pits have been identified, some of which are truly colossal. The largest plunge hundreds of feet into the lunar crust. However, our technology hasn't yet reached the point where we can thoroughly investigate the depths of these chasms. That's what makes a recent revelation so astonishing. It appears that some of these immense pits extend far into the moon's bedrock. This is a discovery of immense importance. Let's delve into why. Behold this massive subterranean cavern. Leonardo Carrer and Lorenzo Brusin, researchers at the University of Trento, were elated to finally confirm the existence of these structures on the moon. They meticulously analyzed images captured by the Miniature Radio Frequency (RF) instrument aboard the Lunar Reconnaissance Orbiter (LRO) back in 2010. The initial images lacked the sharpness we'd expect today. Therefore, the researchers undertook a monumental task, employing cutting-edge data analysis and advanced modeling techniques to unlock the secrets hidden within the data. But first, let's address the fundamental question. Why does this matter so much? Imagine, instead of constructing habitats on the exposed lunar surface, we could potentially reside within these naturally formed caves. These subterranean havens could offer invaluable protection from the perils of space, such as harmful radiation, extreme temperature fluctuations, and even the constant threat of micrometeorites. According to Wes Patterson, a planetary geologist at Johns Hopkins University, even though we would still need to transport materials from Earth to make these caves habitable, utilizing them would be significantly easier and more cost-effective than constructing bases from scratch on the surface. Based on the data gathered, this particular cave measures approximately 150 feet in width and extends up to 260 feet in length, just shy of the size of an American football field. Its location is within a deep depression known as the Mare Tranquillitatis Pit, which likely originated from the collapse of an ancient lava tube. While the moon is devoid of active volcanoes today, billions of years ago, its surface was a landscape of molten rock. Lava rivers flowed through valleys, carving out these subterranean tunnels beneath the surface. Over eons, some of these lava tubes became structurally unstable and succumbed to collapse, resulting in the formation of pits like the one now under intense scrutiny. NASA's Lunar Reconnaissance Orbiter, LRO, has already identified over 200 such pits scattered across the lunar landscape. This suggests that potentially hundreds of hidden caves are waiting to be uncovered on our celestial neighbor. In their publication in the esteemed journal Nature Astronomy, the researchers propose that these caves could provide future astronauts with a secure environment to live and conduct research, shielding them from the moon's unforgiving conditions. And indeed, those conditions are extreme. One of the most daunting challenges of establishing a lunar presence is the temperature. The lunar surface is subjected to scorching heat during the day, reaching a blistering 250 degrees Fahrenheit, 121 degrees Celsius. Then, as night descends, temperatures plummet to a frigid 200 degrees Fahrenheit, 129 degrees Celsius. However, within the confines of these caves, temperatures could remain far more stable. A separate study conducted in 2022 employed sophisticated computer simulations to predict that certain caves could maintain a relatively comfortable temperature of around 63 degrees Fahrenheit, 17 degrees Celsius. Much more manageable, wouldn't you agree? Unfortunately, accessing these lunar sanctuaries won't be a walk in the park. The Mare Tranquillitatis Cave lies over 400 feet below the surface, nestled at the base of a steep slope covered in loose, treacherous debris. Ingenious engineering solutions will be required to navigate this challenging terrain. Options under consideration include the use of jetpacks, the construction of a lunar elevator, or the development of some entirely new technology. We absolutely must devise a reliable method for safely transporting astronauts to and from these subterranean habitats. Furthermore, there's a vast amount yet to be discovered. Advanced radar technology could empower scientists to locate even more hidden caves and extensive lava tube networks beneath the lunar surface. In the future, a spacecraft equipped with high-resolution radar could even create detailed maps of the internal structures of the pits that the LRO has already identified. According to the researchers, this comprehensive survey could be instrumental in determining the optimal locations for future lunar bases and other exploration initiatives. And there's another tantalizing possibility. These caves might harbor water. Scientists have already confirmed the presence of frozen water on the moon, concealed beneath the surface in permanently shadowed craters. Trace amounts are also dispersed throughout the lunar soil. Water is an absolutely vital resource for any prospective moon base, and discovering it within these caves would significantly bolster the feasibility of long-term lunar habitation. In essence, this discovery could be a game-changer for lunar exploration. Living within natural caves on the moon might prove to be a more practical and safer alternative to constructing structures on the exposed surface. It could also propel us one step closer to realizing the dream of establishing a permanent human presence on the moon, where people can live, work, and explore for extended periods. The space crew had dedicated over 3 years to meticulous launch preparations. The training regimen for landing on this alien world included rigorous exercises, collecting and analyzing rock samples in the Grand Canyon, exploring ancient volcanic formations at the Nevada National Security Site, and studying gas and lava vents, lava lakes, and pit craters. They were ready. Imagine a team of astronauts, not in some futuristic spacecraft, but in the heart of Hawaii. Here, in this volcanic landscape, they are preparing for a journey unlike any other. To combat the disorienting effects of microgravity, they learn to walk sideways, suspended by straps, clinging to walls. They push their bodies to the limit, enduring rigorous diets and sleep schedules, all to ensure their safety in the alien expanse of space. Picture the scene. After 3 days, 3 hours, and 49 minutes of relentless travel, they finally touch down. Their destination? The Sea of Tranquility, a place chosen not for its romance, but for its clear visibility and relatively smooth terrain. A pragmatic decision to conserve precious propellant. But upon arrival, an unexpected sensation, a distinct smell. This isn't science fiction. This is the true story of Apollo 11, the mission that landed humans on the moon on July 20th, 1969. Since that monumental day, 12 souls have walked upon its surface. We often think of the moon as a familiar celestial neighbor, yet it remains shrouded in mystery. Consider this. The moon perpetually shows us the same face. This is due to a phenomenon called synchronous rotation, a cosmic dance between Earth and its only natural satellite. It creates the illusion of stillness, but the moon is far from static. In reality, it's slowly drifting away from us, receding at a rate of about 1.5 inches per year. Despite the vast distance of 238,855 miles, the Earth and Moon are inextricably linked. The Moon governs the tides, shaping the very coastlines of our planet. But the Earth, too, exerts its influence on its celestial companion. Our planet is the cause of moonquakes, seismic events that can last for an astonishing 30 minutes, far longer than their terrestrial counterparts. On a balmy summer night, the Moon appears perfectly round. But this is an illusion. The Moon's true shape is oval, distorted by Earth's immense gravitational pull. This gives it a lemon-like form. The lunar surface bears more than just footprints. The American astronauts of 1969 left behind a collection of artifacts: 2 golf balls, a drawing by the iconic Andy Warhol, and even a message from Queen Elizabeth II. One of the last humans to walk on the moon, astronaut Eugene Cernan, etched his daughter's initials, TDC, into the lunar dust in 1972. With no wind or weather to erase them, those letters may remain for eternity, a lasting testament to a father's love. Believe it or not, you can be allergic to the moon. Harrison Jack Schmitt, an astronaut on the Apollo 17 mission, discovered this firsthand. After exploring a valley in the Sea of Serenity, he returned to the lunar module, inadvertently carrying moon dust with him. Upon removing his spacesuit, he experienced a sudden allergic reaction, red eyes, sneezing fits, and other symptoms that lasted for 2 long hours. Given its proximity, it's no surprise that the moon has its own time zone, Lunar Standard Time. However, it doesn't align with Earth's familiar clock. A lunar year is divided into 12 days, each roughly equivalent to a month on Earth. These days are named after the astronauts who walked on the moon, and the lunar calendar begins with Neil Armstrong's first steps on July 21st, 1969, at 2:56:15 Universal Time. The moon's tenuous atmosphere creates extreme temperature fluctuations. Temperatures can soar to 200 degrees Fahrenheit. Near the lunar poles, however, the temperature plunges to a frigid 400 degrees Fahrenheit. For centuries, humans have sought to understand the moon's influence on Earth. In the Middle Ages, scientists and philosophers believed that the full moon exacerbated certain health conditions, leading to the term lunatic for those affected, literally moonsick. And it's not just humans. Dog owners are statistically more likely to visit veterinary emergency rooms during a full moon. Popular culture often associates wolves with howling at the full moon, but scientists have found no concrete evidence to support this connection. It remains, for now, a captivating myth. Imagine, decades from now, astronauts needing to master the art of bricklaying on an alien world. Of course, they won't be doing it all alone. We envision a sophisticated automated system, a ballet of robots working in perfect harmony. Humans will be there, naturally, overseeing the lunar construction site, ensuring everything runs smoothly. Despite this reliance on automation, scientists are preparing us for a rather intimate lunar living experience. Designs might feature stacked living quarters, maximizing space, or multi-purpose areas that adapt to the needs of the moment. However, life on the moon won't be a walk in the park. Prepare for extremes. Picture this: scorching temperatures reaching a blistering 212 degrees Fahrenheit during the lunar day. Then, as night descends, the mercury plummets to a bone-chilling minus 290 degrees. And the weather is just the beginning. The moon is relentlessly bombarded by solar radiation, cosmic rays, and a constant barrage of micrometeorite impacts. All these forces conspire to gradually erode anything left on the surface. Another major hurdle? Lunar dust. The moon has no atmosphere to speak of, and its dust presents unique challenges. This isn't your everyday household dust. This lunar dust is super clingy, almost magnetic in its adherence. It can irritate astronauts, causing sneezing fits and watery eyes, like a case of lunar hay fever. Worse, it can damage equipment and compromise the integrity of spacesuits. It's not something you want to trifle with. Scientists have discovered that this troublesome dust originates from meteor impacts, which shatter the lunar surface, creating microscopic particles and razor-sharp glass shards. It's potentially toxic, and its minute particles can float for extended periods in the moon's weak gravity, making it difficult to breathe. Unlike Earth, the moon lacks wind and rain to cleanse its surface. Now, scientists are intensely studying this lunar dust, seeking ways to mitigate its effects and prevent it from jeopardizing future missions. But there's far more to the moon than meets the eye. Scientists are also eager to explore the mysteries hidden within low-frequency electromagnetic waves. These waves are faint whispers echoing from the farthest reaches of the cosmos. For eons, these elusive signals have remained hidden, drowned out by the cacophony of radio waves and background noise here on Earth. But on the far side of the moon, shielded from our planet's interference, we can finally record and study them. Unlocking the secrets held within these waves could revolutionize our understanding of the universe's origins. This isn't just about Earth or the moon. This is about peering back to the very dawn of creation. Our new lunar laboratory promises to forever reshape our understanding of the cosmos. NASA has ambitious plans for lunar exploration. Their Artemis mission successfully returned to Earth in December 2022 after a month-long voyage into space, venturing far beyond the moon's orbit. This mission validated the capabilities of new technologies, paving the way for future explorations of Mars. The ultimate goal of Artemis is to establish a permanent presence on the moon. This includes creating a lunar gateway, a space station orbiting the moon, to facilitate landings. Artemis 2 is scheduled to carry astronauts into lunar orbit in 2024. And during the Artemis 3 mission, planned for the mid-2020s, 2 astronauts will land near the moon's south pole. It's quite possible that a lunar base will become a reality within the next 2 decades. Stay tuned. We might soon witness the construction of amazing structures on the moon, all thanks to India's recent discovery of sulfur near the lunar south pole. This chemical element could prove invaluable for building infrastructure on our celestial neighbor. This marks the first time sulfur has been detected on Earth's natural satellite. This sought-after element is commonly found near volcanoes on Earth. Its presence on the moon provides valuable insights into the satellite's volcanic history and past atmospheric conditions. The mission's rover detected this element less than a week after its historic landing, approximately 70 degrees from the moon's south pole, on August 23, 2023. This achievement made India the 4th nation to successfully land a mission on the moon. Furthermore, this mission represents the first spacecraft to land so close to the lunar south pole, an area of strategic importance believed to contain deposits of water ice. If confirmed, future missions could potentially harvest this ice and transform it into drinking water or even rocket fuel. For 2 weeks, the lander diligently collected data, primarily focused on analyzing the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover embarked on its mission to locate frozen water on the lunar surface. And the lander achieved another remarkable feat on September 3rd. The spacecraft ignited its engines and lifted itself approximately 16 inches into the air before executing a precise hop, landing 12 to 16 inches away from its original position. This is a significant achievement. The ability to lift a lander off the surface. The largest known crater in our solar system isn't on Earth, but rather on our very own moon. It's called the South Pole Aitken Basin. Imagine a colossal gouge on the far side of the moon, a giant scar measuring a staggering 1,550 miles in diameter. But this immense formation is just one of the many mysteries our lunar companion holds. Consider the strange flashes of light that have baffled observers for centuries. Scientists call these outbursts transient lunar phenomena, or TLPs for short. These aren't just fleeting glimmers. They're much more. For hundreds of years, people across the globe have reported seeing them. One of the earliest recorded instances dates back to 1178, when monks in Canterbury, England, described a flaming torch blazing on the moon's surface after sunset. But TLPs aren't limited to just light flashes. Reports detail a range of unusual events: gas-like mists swirling across the lunar landscape, strange reddish, green, blue, or even violet colorations painting the gray surface, and even the sudden darkening of specific areas. Is something truly strange happening on our seemingly familiar moon? Is this the beginning of a new era of lunar activity? Or are we only now, with our advanced technology, beginning to notice what has always been there? Scientists have put forward various theories to explain these enigmatic events. The unusual flashes could be caused by anything from the impact of small meteoroids to electrostatic discharges crackling across the surface. The problem is, it's incredibly difficult to pinpoint the exact cause of each event, because most observations come from a single observer on Earth or from a single location. The moon also experiences seismic activity, lunar moonquakes, that could explain some of these luminous phenomena. When the lunar crust shifts and cracks, it could release light-reflecting gases, causing them to erupt onto the surface and create those fleeting luminous displays. Some scientists even speculate that residual geologic activity deep within the moon might be responsible. This is quite a revelation, considering we've always thought of the moon as a completely dead and lifeless world. Have you ever noticed how the moon seems to change color? There are actually scientific explanations for this phenomenon. Seen from outside Earth's atmosphere, the moon appears as a brown-tinted gray. But from the surface of our planet, its color seems to shift depending on various atmospheric conditions. A moon near the horizon will often appear yellow or red, the same effect that colors sunsets. A rarer blue-colored moon suggests that you're viewing it through an atmosphere laden with larger dust particles. The moon can even appear purple at times, although the exact cause of this specific hue remains a subject of debate. While the lack of definitive knowledge about the presence and amount of water on the moon is a factor, it's not the primary reason we haven't yet established permanent settlements there. The real obstacle is radiation. Recent studies have revealed that the lunar surface is bombarded with radiation levels 5 to 10 times higher than those experienced during a transatlantic flight. That's a staggering 200 times higher than the radiation levels on Earth's surface. Future lunar missions, like the ambitious Artemis project, must take this radiation hazard into careful consideration to protect the astronauts. Named after Artemis, the sister of Apollo in Greek mythology, this program aims not only to return astronauts to the lunar surface, but also to establish a permanent base there for conducting research in safe conditions. The Artemis project began in 2017, with the first uncrewed mission, Artemis 1, launched in 2022. This mission, lasting approximately 25 days, successfully sent an uncrewed spacecraft into lunar orbit, gathering crucial data for future crewed missions. The next major milestone is Artemis 2, a planned 4-person mission scheduled for launch in May 2024. Following that, Artemis 3, 4, and 5 are projected to launch in 2025, 2026, and 2027 respectively, each with a planned duration of about 30 days, as humanity takes its first steps toward a permanent presence on the moon. Imagine for a moment that we're embarking on a journey, not across continents, but across vast stretches of space and time, to our very own moon. The lunar surface, now a familiar sight, holds secrets crucial for future missions. A testing ground to ensure the safe return of precious soil samples, perhaps even astronauts, after their sojourn on this celestial body. Let's rewind to September. The Indian spacecraft, a marvel of engineering, was carefully placed into a state of slumber. The relentless lunar night, a period lasting a full 14 Earth days, was rapidly approaching. This intrepid machine wasn't designed to gather scientific data under such harsh conditions. But even in its brief period of activity, the mission has already yielded some monumental discoveries. One such revelation involves the temperature of the moon's uppermost layer of soil, measured at various depths. Intriguingly, the surface temperature in that region defied expectations, proving to be significantly hotter than initially predicted. Scientists estimated a temperature range of 68 to 86 degrees Fahrenheit. The reality was a scorching 158 degrees Fahrenheit, a substantial and perplexing difference. The mission also confirmed the presence of a multitude of chemical elements, including the life-sustaining oxygen. Furthermore, the data transmitted back to Earth unequivocally confirms the existence of aluminum, calcium, iron, titanium, silicon, and a host of other chemical elements on the lunar surface, specifically near the South Pole. Adding to the intrigue, the rover was equipped with specialized instruments designed to detect seismic activity, listening intently for quakes and rumbles emanating from beneath the lunar surface. This brings us to the detection of sulfur, a discovery made possible by the rover's sophisticated spectroscope. Scientists are currently engaged in a rigorous investigation, attempting to determine the origin of this element. Did it form naturally on the surface, or is it a byproduct of ancient volcanic activity, or perhaps a cataclysmic meteor strike? But the surprises don't end there. Another astonishing discovery has emerged from the lunar landscape: a rock, potentially the oldest known fragment of Earth itself. This tiny chip, a mere 0.7 inches wide, was found nestled within a larger rock collection brought back to our planet by the Apollo astronauts. It's believed to be a 4 billion-year-old relic from our own world. This extraordinary find could revolutionize our understanding of the intense bombardment that early Earth endured in its infancy. Picture this. Soon after this ancient rock formed, a massive asteroid impact could have violently ejected it from Earth's surface. At that distant time, our planet's moon was positioned 3 times closer to Earth than it is today. The force of the collision was so immense that this fragment of terrestrial rock was propelled all the way to the moon. Over eons, this fragment became embedded within a lunar breccia, a type of rock formed from the fusion of other rocks. Eventually, this remarkable rock made its way back home to Earth, carried by the Apollo 14 astronauts. While meteorites originating from Mars and the Moon had been previously identified, this marked the first instance of a rock from the Moon being definitively identified as a terrestrial meteorite. Further analysis revealed that the rock had formed in a water-rich environment, under temperatures and pressures consistent with those found approximately 12 miles beneath Earth's surface. Now, let's shift our focus to 2019, a year that witnessed another historic milestone in lunar exploration. China's Chang'e 4 mission achieved the unprecedented feat of landing on the far side of the Moon, a region perpetually hidden from Earth's view. The mission's rover played a pivotal role in helping researchers visualize the hidden structures buried deep beneath the lunar surface, unveiling billions of years of lunar history. The Yutu-2 rover accomplished this remarkable feat using its lunar-penetrating radar. This advanced instrument allowed scientists to peer deep into the Moon's subsurface, listening for echoes of sound waves bouncing off structures concealed from direct observation. The findings were astonishing. These structures were found to reside at depths reaching nearly 1,000 feet. The research indicates that the uppermost 130 feet of the lunar surface consist of layers of dust, soil, and fragmented rocks. In addition, the instruments detected a buried crater, likely formed by the impact of a large object crashing into the Moon's surface eons ago. Imagine ancient lava flows coursing deep beneath the lunar surface. Researchers theorized that the fractured rocks surrounding this formation are likely debris generated by the force of the impact. They also observed that the layers of volcanic rock became thinner as they approached the surface. This variation in thickness suggests a gradual decline in the frequency and intensity of volcanic eruptions over time. Thus, lunar volcanic activity steadily diminished since the Moon's formation approximately 4.5 billion years ago. On the far side of the Moon lies one of the largest and oldest impact craters in our entire solar system, the South Pole Aitken Basin. Unfortunately, from our vantage point on Earth, we can only glimpse its outer rim, which appears as a colossal chain of mountains. This gargantuan depression stretches for more than 1,500 miles in diameter, reaching a depth of 8 miles, and encompasses roughly 1/4 of the Moon's total surface area. Astronomers are convinced that this massive crater was formed when a large asteroid collided with the Moon approximately 4 billion years ago. And now, consider this. Hidden approximately 180 miles beneath the Moon's surface, somewhere within the South Pole Aitken Basin, lies a gigantic mass of metal comparable in size to 4 Connecticuts. To give you an idea of its weight, let's just say that the number contains 18 zeros. This enigmatic mass was discovered by GRAIL, NASA's Gravity Recovery and Interior. Imagine for a moment a secret hidden beneath the lunar surface. Decades ago, a lunar prospector mission, an ambitious endeavor to map our celestial neighbor, began sending back a wealth of data. As scientists meticulously pored over the information beamed back from the Moon, they stumbled upon something truly perplexing. A localized anomaly in the Moon's gravitational field. Further investigation revealed that a significant, unidentified mass was exerting its influence on the very structure of the South Pole Aitken Basin, a vast impact crater on the far side of the Moon. What could be the source of this mysterious gravitational pull? To this day, the exact nature of this lunar enigma remains unsolved, but several compelling theories have emerged. One intriguing hypothesis suggests that this dense mass is a remnant of the Moon's primordial past, a massive concentration of metallic oxides formed during the satellite's infancy. Picture the early Moon, a swirling sphere of molten rock slowly cooling and solidifying. As the lunar magma ocean gradually crystallized, pockets of dense oxides may have coalesced, forming the anomaly we detect today. However, a more widely accepted theory points to a cataclysmic event that forever altered the lunar landscape. The colossal impact that created the South Pole Aitken Basin itself. This impact, scientists believe, was caused by a massive asteroid, a space rock of immense size and density. According to this theory, the gravitational anomaly is the iron-nickel core of that very asteroid, embedded deep within the lunar crust. But the mysteries of the Moon don't end there. Consider the possibility of vast, subterranean networks of lava tubes hidden beneath the dusty surface. Recent topographical surveys have revealed tantalizing evidence of enormous caverns lurking beneath our feet, the legacy of ancient lunar volcanism that raged billions of years ago. Imagine rivers of molten lava coursing beneath the lunar surface, solidifying on the outside to form a protective crust while the molten interior continued to flow. Over eons, these subterranean lava flows carved out extensive tunnel systems, leaving behind vast, empty caverns. NASA's discovery of numerous small pits on the Moon's surface may be the very entrances to these hidden lava tubes. If these theories hold true, these lunar lava tubes could offer more than just shelter. They might also provide crucial resources for future astronauts, potentially serving as repositories of water ice, a precious commodity in the harsh lunar environment. Now picture a sleek granite countertop, the kind you might find in a modern kitchen. Surprisingly, the raw materials for such a countertop might also exist on the Moon. While lunar granite production is still a distant dream, the building blocks are potentially there. Moreover, the presence of granite on the Moon could provide valuable clues about the satellite's watery past. It began with the discovery of an unusual heat signature on the far side of the Moon, traced back to a massive deposit of granite buried beneath the surface. Granite, a relatively common rock on Earth, is surprisingly rare elsewhere in the solar system, making this discovery particularly significant. Scientists believe this lunar granite formation is associated with an ancient volcano, dormant for approximately 3.5 billion years, yet still radiating heat. Using advanced microwave technology, researchers measured the temperature beneath the lunar surface, revealing a region spanning approximately 31 miles in diameter that is significantly warmer than its surroundings. This hotspot lies directly beneath a collapsed area, rich in silicon, a region reminiscent of terrestrial volcanic craters, albeit without the active lava flows. The researchers even drew comparisons to iconic granite formations on Earth, such as El Capitan and Half Dome in Yosemite National Park. These majestic rock formations, geological wonders that inspire awe and wonder, are composed of the same material as this hidden lunar deposit. The implications of this discovery are profound. Granite formation on Earth typically requires the presence of water and the dynamic processes of plate tectonics. The moon, however, lacks both of these key ingredients. So, how did granite form on a seemingly arid and geologically inactive world? This lunar granite discovery could revolutionize our understanding of planetary formation. While granite is abundant on Earth, its scarcity elsewhere in the solar system makes its presence on the moon all the more intriguing. The discovery could offer valuable insights into the moon's early history, shedding light on its volcanic activity and the potential presence of water in its distant past. Without water and plate tectonics, the formation of granite becomes a formidable challenge. Yet, against all odds, granite exists on the moon. Did the moon once harbor water in this specific location? Or did some other unknown process facilitate granite formation in the absence of water? These are the questions that scientists are now grappling with, seeking to unravel the mysteries of the lunar past. The question of water on the moon remains a central theme in lunar exploration. The moon, currently drier than the Sahara Desert by a factor of 100, has long been the subject of debate regarding its water content. However, in 2020, NASA's SOFIA mission provided definitive evidence of water molecules, H2O, present on the sunlit surface of the moon, clinging to grains of lunar dust. Centuries ago, in 1645, early lunar observers were captivated by the dark patches that adorn the moon's surface. Dutch astronomer Michael van Langren meticulously mapped these features, christening them Maria, Latin for seas. Alas, these dark regions are not bodies of water, but rather expansive plains of basalt, solidified remnants of ancient lava flows. Imagine a world without the protective embrace of our atmosphere, a world scorched by the sun and bombarded by cosmic radiation. We're talking about the moon, a celestial body that for centuries was believed to be utterly barren. Once, vast dark plains known as Maria were thought to be seas, remnants of Ansi and volcanic eruptions. Today, we still use the term Maria, a testament to early astronomical misconceptions. Back in 1892, an American astronomer named William Pickering made a crucial discovery. The moon possessed virtually no atmosphere, no clouds, and therefore no chance for water to exist on its surface. For many years, the scientific consensus was that the moon was as dry as the most arid desert on Earth. Then, in the 1960s, a theoretical physicist named Kenneth Watson proposed a revolutionary idea. He suggested that water ice might actually exist in the perpetually shadowed craters of the moon, regions that never receive direct sunlight. These areas are called permanently shadowed regions, and the concept was mind-blowing for the time. The Apollo missions, those daring voyages from 1969 to 1972, finally provided the opportunity to search for water on the moon up close. Astronauts collected soil samples, but initial analysis revealed no traces of water. The prevailing view reverted. The moon was bone dry. But the story doesn't end there. In 1994, NASA's Clementine mission offered new hope, suggesting the possible presence of ice within those shadowed craters. Further bolstering this theory, in 1998, the Lunar Prospector mission detected evidence of hydrogen concentrations in the permanently shadowed areas, a strong indication of water ice lurking at the lunar poles. The images weren't crystal clear, but the discovery sent ripples of excitement through the scientific community. Finally, in 2008, scientists revisited the Apollo samples with fresh eyes. Reanalyzing the old data, they uncovered subtle hints that water might have been present after all. It was akin to unearthing buried treasure in one's own backyard. The moon, as it turns out, is a surprisingly promising destination. It even holds the building blocks to produce your food supplements. Calcium, magnesium, you name it. But before you start envisioning lunar feasts, know that munching on raw lunar minerals isn't the ideal way to boost your diet. However, these elements have a multitude of other applications. Calcium, for instance, is the fourth most abundant element residing in the lunar highlands. And here's where it gets interesting. Pure calcium metal is incredibly flexible and, in the absence of oxygen, conducts electricity with impressive efficiency. Who would have guessed? Anorthite, a rare gem on Earth, is a key component for calcium on the moon. It can even play a role in creating advanced silicon-based solar cells. The recipe for lunar solar success includes lunar silicon, iron, titanium oxide, and, of course, our friends calcium and aluminum. And what about precious metals? The moon has those too, including gold. In 2009, during a lunar mission, NASA detected gold in the lunar soil. A spacecraft positioned directly behind the rocket was equipped with a sophisticated spectrometer. Its purpose to analyze the debris cloud created when the rocket impacted the surface. The analysis revealed a variety of chemicals, including carbon monoxide, carbon dioxide, ammonia, sodium, hydrogen, and even traces of mercury, gold, and silver. Now, it's been some time since that discovery, almost a decade and a half. Accurately measuring the gold content has proven to be a significant challenge. The gold is buried deep beneath the lunar regolith, making precise quantification difficult. So, metals are present, and lunar water may have existed. But what about food? The good news is that scientists believe plants can indeed grow on the moon. Don't expect a sprawling orchard, though. Envision a modest garden with a few carefully cultivated beds. Let's rewind a bit. The Apollo astronauts collected samples of lunar surface material, known as regolith, and brought them back to Earth. 50 years later, NASA decided to use 3 of these samples to attempt growing plants for the first time. They used regolith collected from beneath the lunar rover's bumper. The team added water and seeds to the samples, allocating 1 gram of regolith to each plant. These were then placed in a clean room and supplied with nutrient solutions daily. The experiment was a success. During this undertaking, scientists cultivated small plants, such as mustard greens, in the nutrient-poor lunar soil. Of course, you'd still need to import olive oil from Earth to dress them. The conclusion: plants can in fact grow in lunar soil. However, they won't be as robust and healthy as those grown in Earth's soil or even in a control group using a lunar simulant made from volcanic ash. But this is merely the beginning. The question remains: what other treasures does our moon conceal? Remember the gold rush of the 19th century? Prospectors flocked to California's rivers, pan in hand, driven by the lure of wealth. Scientists now suggest that a lunar gold rush might be on the horizon. Apparently, precious metals valued at over $1 trillion could be hidden beneath the lunar surface. That's a staggering amount of money. But can we realistically access it? And if we do, who does it belong to? Imagine gazing up at the moon on a clear night. Have you ever truly considered the scarred surface of our celestial neighbor? It's riddled with holes, resembling a colossal chunk of Swiss cheese floating in the inky blackness. Our moon bears the marks of countless impacts, a staggering 1.3 million craters in total, if we include those exceeding a mere 6 meters in diameter. But let's focus on the truly immense ones, the giants stretching over 12 meters wide, some 6,500 in number. These aren't the work of mischievous aliens or subterranean creatures, but rather the result of relentless bombardment by asteroids crashing into the lunar surface over eons. Scientists poring over detailed scans of the moon and comparing them to the composition of meteorites have arrived at a tantalizing conclusion. They believe a fortune in platinum and other precious metals lies hidden within these impact craters. And the really exciting part? Much of this treasure trove could be located just a few feet beneath the surface. The moon, lacking Earth's protective atmosphere, is a remarkably well-preserved time capsule. There's no wind, no rain, no seismic activity to disturb the landscape. This means that the asteroids, upon impact, deposited their valuable metallic cargo directly onto the lunar surface, where it has remained virtually untouched in the lunar dust for millions upon millions of years. Each crater acts like a giant cosmic bowl, collecting platinum, iridium, palladium, and other rare and valuable metals. Here on Earth, we have to drill miles deep, expend enormous effort and resources just to extract a tiny amount of these elements. Speaking of Earth, did you know that most of the accessible gold we mine today likely originated from ancient meteorites? When our planet first formed, nearly all of the original gold sank into the Earth's core, becoming inaccessible. The gold we currently extract from the Earth's crust is believed to be the remnants of space rocks that collided with our planet billions of years ago. So, why not simply mine asteroids directly? The answer is distance. While theoretically possible, mining asteroids is incredibly challenging due to their remote locations and unpredictable trajectories. The Moon, on the other hand, is relatively close and easily accessible. We've already walked on its surface, collected samples, and returned them to Earth. We're intimately familiar with its terrain. This makes lunar mining a far more logical and achievable first step than chasing after rogue asteroids. Though, make no mistake, asteroid mining remains a tantalizing prospect for the future. Moreover, the potential rewards of lunar mining extend beyond precious metals. Some of these craters harbor a hidden treasure, frozen water. Multiple missions, including NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have detected significant deposits of frozen water ice in permanently shadowed craters near the Moon's poles. This ice is an incredibly valuable resource. It can be broken down into its constituent elements, oxygen and hydrogen. These elements are the fundamental components of rocket fuel. The water can also be purified for astronauts to drink, or even used to cultivate plants in lunar habitats. Imagine the possibilities. Spaceships refueling directly on the Moon before embarking on voyages to distant planets. Not only is this a compelling vision, but it's also a highly economical and practical one. It would save us immense amounts of money and effort, making deep space exploration far more feasible. And if we're already establishing refueling stations, why not go a step further and create a permanent lunar base? This would transform the Moon into a strategic launchpad for exploring the vast expanse of space. A moon base would provide scientists with an unparalleled opportunity to study the harsh realities of space weather, experiment with habitat construction techniques, and test robotic systems in the unique environment of the lunar surface. I, for one, eagerly anticipate a future where robots are streaming live footage from the Moon, offering us unprecedented insights into this alien world. The skills and knowledge we acquire on the Moon will be invaluable for future endeavors, such as establishing settlements on Mars or exploring the moons of Jupiter and beyond. This isn't mere science fiction, it's a rapidly approaching reality. Companies like Astroforge and Carmen Plus are actively developing the technologies needed to mine asteroids and, eventually, the Moon. NASA's Artemis program is aggressively pursuing the goal of establishing a sustainable human presence on the Moon within the next decade. And the European Space Agency is also keenly interested in exploiting lunar resources. The concept of humans and robots working side by side on the Moon is no longer a distant dream. It's a matter of when, not if. However, the path to lunar colonization is not without its challenges. Just as with the original gold rush, the rules governing lunar resource extraction are currently ambiguous. The Outer Space Treaty of 1967 prohibits any nation from claiming sovereignty over the Moon. However, it remains silent on the issue of private companies mining lunar resources. So, if a company builds a rocket, extracts platinum from the lunar surface, does that platinum belong to them? As of now, the answer is unclear. Nations are engaged in ongoing debates and negotiations to establish a legal framework before the space gold rush descends into a chaotic free-for-all. Another critical challenge is protecting the Moon's delicate and unique environment. Some lunar craters are so radio-quiet that scientists envision transforming them into giant space observatories, capable of studying the universe without interference from Earth-based radio emissions. Mining operations in close proximity could disrupt this pristine environment, generating dust and vibrations that could compromise sensitive scientific instruments and jeopardize billion-dollar experiments. Such disruptions would undoubtedly anger researchers. Furthermore, certain regions of the Moon remain completely untouched, representing invaluable scientific resources. Unregulated mining could irrevocably damage these pristine areas, erasing vital clues about the Moon's history and the early solar system. Imagine a world beyond our own, a celestial body that has captivated humanity for millennia, the Moon. But beneath its familiar cratered surface lies a treasure trove of resources, a new frontier beckoning us to explore its hidden potential. However, as we stand on the precipice of this lunar gold rush, a crucial question arises. How do we responsibly unlock the moon's riches without turning it into a cosmic construction site? We must ensure that the pursuit of lunar resources doesn't obliterate the moon's scientific value. Some experts propose establishing protected zones, lunar equivalents of Earth's national parks, where mining and heavy machinery are strictly prohibited. This would allow us to harness the moon's potential while safeguarding its most precious areas for research and discovery. But what about us, the casual Earthlings who won't be donning spacesuits and wielding metal detectors on the lunar surface? How will lunar mining impact our lives? The moon's rare metals possess incredible value and could revolutionize future technologies. Platinum group metals, potentially abundant in lunar soil, are essential components in medical equipment, satellites, and advanced batteries and fuel cells. If the moon truly holds a trillion-dollar treasure, it could fuel technological advancements and potentially lower costs here on Earth. Then there's helium-3, a rare isotope found on the lunar surface. Scientists believe it could be the key to unlocking nuclear fusion, a clean and powerful energy source that produces no greenhouse gases or long-term radioactive waste. If fusion becomes a reality, even small quantities of helium-3 could power entire cities, ushering in an era of clean and sustainable energy. Harnessing resources from space could also reduce our reliance on environmentally damaging mining practices on Earth. This would mean less destruction of our planet and more sustainable ways to meet the growing demands of our population. However, this new frontier also presents challenges. A cosmic tug-of-war is inevitable as nations and corporations vie for access to the moon's resources. No one wants to be left behind in this lunar gold rush. The bottom line, lunar mining is not just a scientific endeavor. It has the potential to reshape economies, revolutionize technology, and impact the Earth's environment, for better or for worse. Remember those science books from childhood filled with visions of moon bases? The high costs and lack of immediate economic return have historically hindered lunar exploration. But with the prospect of vast resources awaiting us, everything could change. Imagine a future where humans work 9-to-5 jobs on the moon, repairing robots and cultivating lunar plants. However, let's return to Earth for a moment. We're not quite ready to book lunar Airbnbs or grab a moon McDonald's. Even the most optimistic experts believe that large-scale mining operations and permanent lunar bases are still decades away. For now, lunar missions will primarily be robotic and experimental, with price tags that will leave you breathless. So, until we're all sporting moon mining helmets, it's something to contemplate while gazing at the night sky. What secrets and riches lie hidden on the bright side of the moon? But the moon holds more secrets than just surface resources. Deep within its core, something unexpected is stirring. Not a dramatic shift visible from Earth, but a hidden layer of what scientists are calling moon goo. Remember those school lessons about the Earth's crust, mantle, and core? The moon, like our planet, is composed of these layers. However, the moon's core is significantly smaller than Earth's. Our planet's core makes up about a third of its total mass, while the moon's core accounts for only 1 to 2%. Its diameter is roughly 1/5 of the moon's overall diameter. Surrounding this core is a hard, rocky mantle, but nestled between the mantle and the core lies this mysterious goo layer, and it's far more significant than previously thought. This layer is soft and partially molten, flowing like the tides of our oceans. It expands and contracts, stretches and shifts, almost as if it were alive. Its movements are subtle and regular, not chaotic. We've always known that the moon influences our oceans, causing tides through its gravitational pull, but it turns out that Earth exerts its influence in return. This molten goo ocean reacts to the gravitational dance between our planet and the sun. Furthermore, this molten layer may be composed of ilmenite, a fascinating material rich in titanium. Titanium is a strong and lightweight metal highly valued on Earth. It's used in everything from aircraft components and spacecraft to medical devices and everyday items like bicycles and laptops. Its strength, resistance to corrosion, and heat tolerance make it invaluable. If the moon harbors a molten layer rich in ilmenite, it would be a game changer. Astronomers are already planning for lunar bases, and the presence of readily available titanium would greatly accelerate these efforts. Imagine, for a moment, that we could extract raw materials directly from the lunar surface. A material ready-made for construction, for building spacecraft, even crafting specialized tools for astronauts, right there on the moon. This would completely revolutionize space exploration. Otherwise, we're stuck hauling everything from Earth, a venture of astronomical cost. But now, we have concrete evidence that the moon is far more than just a cold, inert rock. It's a dynamic world, alive with hidden forces churning beneath its surface, almost breathing. To uncover these secrets, NASA deployed cutting-edge technology, the Gravity Recovery and Interior Laboratory, GRAIL, and the Lunar Reconnaissance Orbiter, LRO. These aren't your typical telescopes gazing at the surface. Instead, they're designed to measure phenomena invisible to the naked eye, like subtle variations in the moon's gravity field. The GRAIL mission was ingenious. It involved two small spacecraft, aptly named Ebb and Flow, orbiting the moon in tandem. These spacecraft flew in close formation, meticulously measuring the tiniest fluctuations in lunar gravity. Imagine them feeling the moon's invisible pull, like sensing changes in the texture of an unseen landscape. If the gravity was stronger in one area, the spacecraft would drift closer together. Weaker, and they'd separate slightly. This allowed scientists to map the moon's interior structure without ever setting foot on its surface. In a planned finale, both spacecraft were intentionally crashed into the moon in December 2012, marking the end of their mission. The Lunar Reconnaissance Orbiter takes a different approach, capturing incredibly detailed images of the lunar surface and gathering crucial data about its composition. By combining data from both GRAIL and LRO, scientists were able to detect this intriguing goo layer. This discovery has thrown a wrench into our previous understanding of lunar geology. How did this molten layer form? How long has it been there? And perhaps most perplexing, how has it managed to stay warm for millions upon millions of years? These are profound questions that could reshape our understanding of the moon. The moon, like Earth, possesses a core that generates heat. However, it's not as simple as attributing the molten layer to core heat. The lunar core is significantly smaller and less active than Earth's, meaning it produces considerably less heat. Furthermore, the moon is a much colder place overall. With surface temperatures plummeting to 200 degrees Celsius, how can this internal layer persist in a molten state? The answer remains elusive. Nevertheless, this discovery could explain many lunar mysteries. For instance, astronomers have long been puzzled by moonquakes and their origins. The presence of this semi-molten layer, shifting and moving beneath the surface, could be the key. But the implications extend far beyond our moon. If the moon, which we considered a static, unchanging rock, harbors such dynamic internal activity, what about other celestial bodies? Could planets, moons, and asteroids across the solar system conceal similar hidden movements beneath their surfaces? Unlocking these secrets could even help us better understand our own planet, shedding light on tides and other geophysical processes. Recently, another incredible discovery has been made. Massive caves hidden beneath the lunar surface for eons. For over half a century, scientists have suspected the existence of vast underground networks of tunnels and caves on the moon, known as lava tubes. These formations are, as the name suggests, the result of ancient volcanic activity. Millions of years ago, the moon was a far more volatile place, experiencing frequent volcanic eruptions. When volcanoes erupted, lava flowed across the landscape. As the surface layer cooled and solidified, it formed a protective roof of dark, hardened material. These are the dark patches we observe on the moon's surface today, the remnants of ancient lava flows. Beneath this crust, hot molten lava continued to flow. Once the eruption ceased and the lava drained away, it left behind a hollow tunnel, a lava tube. We see similar formations on Earth in volcanically active regions like Hawaii and Iceland. However, the lunar lava tubes dwarf their terrestrial counterparts. In fact, they are believed to be among the largest and longest in the entire solar system. One such cave system was discovered beneath Mare Tranquillitatis, the site of the Apollo 11 landing, reaching a depth of at least 340 feet. These vast networks of lava tubes have remained hidden just beneath the surface, untouched for millions of years. Now, scientists have finally confirmed their existence. Researchers from the University of Trent in Italy employed advanced radar technology and sophisticated computer analysis to peer beneath the lunar surface. These techniques use radar waves to penetrate the ground, bouncing back and providing clues about what lies hidden below. By analyzing, imagine a future where humanity has a foothold on the moon. Researchers, using advanced wave reflection technology, can peer beneath the lunar surface, charting the hidden network of caves and tunnels that honeycomb the moon's interior. The way these waves bounce back allows them to discern the shape and size of these subterranean spaces. And here's the kicker. These caves could be the perfect location for lunar bases, offering natural protection from deadly radiation, relentless solar winds, and the constant threat of meteoroid impacts. NASA has even uncovered evidence suggesting that some of these lunar caves maintain a remarkably stable temperature of around 64 degrees Celsius. Imagine that, a balmy, consistent climate deep beneath the desolate lunar surface. And it gets better. There's a strong possibility that water ice exists within these caves, a vital resource for future lunar colonists. Humans could potentially take refuge within these natural tunnels, constructing entire self-sustaining colonies within the moon itself. Now, I know what you're probably thinking. What about lunar monsters lurking in the shadows? Could some unknown creature be lurking in the darkness? While the potential for exploration and discovery within these caves is immense, the likelihood of encountering actual animals or monsters is extremely low. The harsh conditions simply wouldn't support the evolution of complex life forms. But hey, it would certainly make for a fantastic horror movie. Currently, the plan is to deploy robots and drones to meticulously map these tunnels, assessing their stability and safety before sending in human explorers. And it's not just the United States that's interested in lunar colonization. China is also actively investigating the potential of these moon caves as future habitats, signaling an intensifying race to explore and ultimately settle on the moon. Have you ever gazed upon the far side of the moon? Unless you've seen the photographs, the answer is almost certainly no. Have you ever wondered why the two sides appear so drastically different? The fact is, we on Earth can never directly observe the far side of the moon. It's a common misconception that the moon doesn't rotate, but that's simply untrue. The moon does rotate, but its rotation is synchronized with its orbit around Earth. This phenomenon, known as synchronous rotation, is a specific type of tidal locking. The first glimpse of the far side of the moon wasn't until 1959, thanks to the Soviet Luna missions, followed later by the American Apollo program. When Luna 3 and subsequent spacecraft transmitted the first images of the far side, they revealed a heavily cratered landscape strikingly similar to the surfaces of Mercury or Jupiter's moon Callisto. It was a stark contrast to the familiar near side we see from Earth. This is when we realized just how different the far side truly is. The near side boasts a thinner, smoother crust, adorned with dark patches known as lunar maria. Vast plains of solidified lava from ancient volcanic flows. And when we say ancient, we're talking over 3 billion years old. In contrast, the far side's crust is significantly thicker and densely packed with craters. Ancient lava flows had minimal impact on this side, leaving the impact craters largely untouched. The far side is also conspicuously devoid of large-scale maria, giving it an appearance reminiscent of dried-out cheese. Let's be honest, the near side is undeniably more visually appealing. But it wasn't until about 50 years ago that we began to understand the underlying reasons for these stark differences. Scientists discovered that the two sides even differ in their geochemical composition. Furthermore, the crust on our side is several miles thinner than on the far side. But how did such profound differences arise on what is essentially a giant floating rock? This became a major scientific puzzle. Numerous theories emerged, with the melted moon theory gaining prominence for a time. This theory posits that Earth itself is responsible for the moon's asymmetrical appearance. It all began billions of years ago, when a Mars-sized object collided with the early Earth. The impact ejected a massive amount of debris into space, which eventually coalesced to form the moon. Initially, this newly formed moon was much closer to Earth, about 15 times closer than it is today. Some scientists have even created visualizations of this early moon, depicting it as a bizarre, boiling sphere of molten rock. Almost immediately after its formation, the moon became tidally locked with Earth, always presenting the same face to our planet. In the aftermath of the collision, Earth was a fiery, incandescent inferno, with surface temperatures reaching a staggering 4,500 degrees. Because the moon was tidally locked, one side was constantly exposed to this intense heat, causing it to partially melt. This could explain why the lunar mantle is thinner on the near side compared to the far side. As Earth boiled, certain elements evaporated and subsequently settled on the moon, potentially explaining the differences in geochemical composition between the two hemispheres. However, this theory has a significant flaw. Where did the rare exotic elements found on the near side come from? Elements like unusual isotopes of phosphorus, potassium, and tungsten. These elements couldn't have originated from Earth, leaving a major question unanswered.